Hello, now we are going to deal application of Schrodinger wave equation, in which first one is particle in a box. What does it mean? Let us consider from figure. What I have drawn here, this is a box whose height is infinite. This is taken to be x direction. A particle having mass and velocity is free to move in this box. Clearly, there is no interaction energy of this particle, because this particle will not interact in this box. So when we find potential energy of this particle in this region, obviously this is V is equal to 0. And if we take this point as 0 and this point as L, it is also clear that when this particle will interact here on the wall, it will get reflected from this wall. So at x is equal to 0 as well as at x is equal to L, the value of potential energy is 0. So we can say that in region 0 to x to L, value of potential energy is 0. This is potential energy, or we may say interaction energy, and it is also clear V tends to infinite. It means interaction energy will be infinite for this particle if it will come out. But since this is infinite, so we will deal in this box only. Now we will use Schrodinger time independent wave equation. It is del square psi plus 2m upon h cut square del square psi plus 2m upon h cut square E minus V psi is equal to 0. What we are doing here, we have taken Schrodinger time independent wave equation. Since for free particle interaction energy or potential energy is 0, so this equation reduces to like this. Now look, we can see here, this is taken as k square. So this one, and since we are treating for only x direction, that is for one dimension. So for one dimension, this equation reduces to del square psi upon del x square plus k square psi is equal to 0. Now we have obtained differential equation of particle in a box. Now we will solve using mathematics. So consider solution. Solution of above equation, let as psi is equal to a sin kx plus b cos kx. Now we will use boundary condition to obtain wave function. What is boundary condition? As we have discussed here, at boundary, that is at point 0 and at point L, at this point V is 0 and also psi will be 0. So first let us see boundary condition. For boundary condition, we are using psi is equal to 0 at x is equal to 0, because at x is equal to 0, when particle strike at the wall, it get reflect, so there will be no particle. And at x is equal to L as well, these are ends of the wall. Using this boundary condition, we are going to solve this equation. Now solve this one. So first we will use this one and then this one. So use this here. What we get, first for this one, when x is equal to 0, this psi is 0, x 0, it means sin 0, sin 0 means 0, so a into 0 means 0, plus again 0, x 0 means cos 0, cos 0 means 1, so b. So what we find, this is the value of b is equal to 0. Now we will use second point, this one, again in this equation. So we have obtained b square to 0 also, we will also use here. So again psi is 0 at x is equal to L, so we will put here a sin kl, and obviously plus b is 0, so this term will be 0. Now we will find, since a and b are constant, so since a is equal to not 0, this implies sin kl is equal to 0, and obviously we know for sin n pi is equal to 0, sin n pi and sin theta is equal to 0, then sin theta is equal to 0, then theta is equal to n pi. We will use that relation here. Now come across once more. as we have proceed up to sin kl is equal to 0, means sin theta is equal to 0, then theta is equal to n pi. This implies kl is equal to n pi. So the value of k is n pi by l. Just we have let 2m upon h cut square is k square. So squaring both the sides, k square is equal to n square pi square upon l square, and the value of k square is 2me upon h cut square is equal to n square pi square upon l square, and we get value of E is energy, total energy, n square pi square h cut square upon 2m l square. Now this is very important equation of energy. Yes, this is quantization due to n. We will talk about this one after. Now we will proceed toward wave function, because we have to find wave function also. So use again psi is equal to, we are using this relation again, since we have obtained the value of k b is 0, it means psi will be a sin n pi by l into x, because k is equal to n pi by l. We have find here. So using that value, we will come across from this equation again, psi is equal to a sin n pi by l into x. Here a is constant. We will find this constant using normalization condition. Now, what is normalization condition? Applying normalization condition, we know that this is psi x psi star x dx is equal to 1. We are using dx because we are talking about only one dimension, and this limit 0 to L. Psi star means this is complex conjugate of psi. So since there is no I, so there will be no effect. It means what is psi, as same psi star will be here. Now putting the value to find value of A, 0 to L, A sin n pi x by L, A sin n pi x by L dx is equal to 1. Now we will integrate it. So this is the A star. You can write mod A square 0 to L sin square n pi x by L dx is equal to 1. Now we are going to integrate this portion. To integrate this one, we will use relation cos 2 theta is equal to 1 minus 2 sin squared theta, so that we will convert as mod A square 0 to L 1 minus cos 2 theta means 2 pi nx by L and by 2. By 2 means we can proceed by 2, so outside, and this is dx is equal to 1. Now separate this one, you will get mod a square by 2 integration 0 to L dx minus 0 to L cos 2 pi nx by L dx is equal to 1. Obviously this is x. When we will put value, this will be L minus 0, that is L. So mod square by 2, this is L minus, now to integrate this one we will use formula cos x, that is, yes, we know in terms of sin x. Now integrating, so we get sin 2 pi nx by L, and again this one, this will be upon 2 pi n upon L. This is up to 0 to L is equal to 1. Proceeding to L minus, when you will put here value L, this will be L cancel out, so sin 2 pi n, we can write L 2 pi n, this will be sin 2 pi n, and when we will use 0, this will be 0 means sin 0, so minus sin 0 is equal to 1. Clearly sin 2 pi n, this will be 0, so 0 minus 0 0 into 0, this will be also 0, so this term will be 0. It means what we get, mod square by 2 L minus 0 is equal to 1, which means mod A is under root 2 by L. As we know that we have found wave function in the form psi x is equal to, just we have found a sin n pi x by L. So the value of a is now under root 2 by L sin n pi x upon L. This is psi x. Again we have here n, as in case of E also. So we have found wave function for particle in a box.